So I wasn't planning on doing a part two to the original video, but since I own both of these, I thought, well, why not open them up and see how they're made and maybe learn something? I know I'm going to learn a few things in this video without a doubt, and you can as well. And this really is a great comparison for what you A, get for your money when you spend more money, and B, just a difference in thought process behind something. And it goes with everything, not just welders. When you look at a tool that was specifically designed for a job and what would be more or less considered a professional level tool, and you compare it to like an entry level, it really doesn't matter what the tool is, the differences tend to be significant. Now, the simpler the tool, the less the difference there is. Like when you look at, say, a $20 hammer versus a $50 hammer, well, how much difference really depends. If you rely on it all day, maybe one of them's less fatiguing, but I think you understand what I'm saying. In a case of welders, which you got to think of modern welders more as computers and less of just a transformer in a bucket. And when you start looking at welders from that thought process, you can see, especially when we get these things opened up, the differences in thought on how to attack the same problem, which the problem the welder needs to solve is how to get the dangerous, angry pixies in the wall to some safe level that you can play with and not electrocute yourself. So that's what these really do, and make it fun too while you're doing it. So anyways, we'll start with this guy. Now, I'll be honest. I opened up both of these and just took a quick gander over them. I didn't really look at them in depth, and the reason I had to is this one right here, I honestly didn't know if I would be able to open or not because it has screws from every which direction. I didn't know what screws mattered, what didn't. Pretty difficult to figure out. It wasn't hard to open, but it could have been way worse than it was. So I went in with kind of like I better be careful. So rather than spending 40 minutes filming and having my battery die opening that on camera, I just did it off camera. But with that said, let's start with this guy and we'll look at how it's made. All right, now that we got this tuna can open here, I want to just cover two things really quick, guys. One, if you so choose to open up a welder you have, make sure you unplug it from the wall, okay? And two, be very careful poking your dipstick around in here. And the reason is these here, which are capacitors, and there's other capacitors in here as well, and you might not even see them. They can hold a charge even when it's not plugged into the wall, which can ultimately shock you. And there's more than enough potential to potentially send you to the ER or to the undertaker. So don't be poking your finger around here if you don't know what you're doing. And on that caveat, there are safeties built into some welders where when you shut them off or unplug them, whatever, that they run the fan down to discharge the capacitors. And that's kind of like a safety thought process. Not all welders do that, so be careful. So anyways, opening this thing up, my first thought is that it's a very simple design, which simple isn't bad, but there's really nothing too overly fancy going on in this. But I kind of expected that because it's not like it has digital displays or buttons to push to adjust settings. It doesn't need a lot of the computer stuff that you would expect to find in more modern style welders with all of that digital crap on them. So that's kind of interesting. Is it good? Is it bad? Well, it's a simple design. Now, speaking of that simple design, I have a feeling that if you own this welder and it's older than the generation that this is, that if you opened yours, you might see different components inside. And the reason I say that is because I've opened up 3 of those titanium 125 flux machines, and every one of them was noticeably constructed different. And that's something with Harbor Freight that you'll learn is that they oftentimes, when you look at the box, they'll have a part number on the box, right? Say a 5 or 6 digit SKU number. When you look on like a sale ad on the email from Harbor Freight, it'll say the welder, like titanium 225, and then it'll say like 4 part numbers. Well, they all look the same, but those part numbers are likely very, very different internally. So don't be alarmed if what you opened up at your home looks different than this. I would kind of expect that, and that's because these are all made in different factories, and the case is typically the only thing that will be identical. Everything else inside will be varying, okay? So let's get into the meat of this a little bit. So a couple things I'm going to mention out right away. This uses conventional PC power fans, which is fine. It uses 2 of them in a row. And that's kind of a smart idea because the air that comes in through here likely gets pushed out that way through the back. So the important components like the IGBT modules, which are likely underneath here, or if it uses MOSFETs, whatever it has for that, the bridge rectifier this likely has in here, is all, you know, decent, big, thick aluminum heat sinks, and the air pattern pretty much puts all of the heat producing stuff right in line of the airflow, so they probably won't get too hot. Now, this machine at max output has a pretty low duty cycle, but most of us at home aren't going to be welding at 225 amps of stick anyways, let's be honest about it. So for your standard 1/8 inch rods and 532 here and there, this should do just fine with the cooling. I wouldn't be too worried about it. And I noticed here, so this little thing here and these 2 little wires, that must be the thermocouple that determines temperature. I do not see one over here. So when this basically either forms a completed circuit or breaks a circuit due to the heat on that, it will trip the welder out to where the welder stops welding, and then it will flash a light on the front, okay? So that, I mean, pretty typical. I'm kind of surprised it doesn't have multiple of them, but one should do it, especially if this is what gets hotter. I'm not, to be honest, this may be a bridge rectifier here for the output. I'm not sure. There is a wiring diagram of this available that I found online. The problem is that I looked at it and it did not seem accurate to this model, because some of the things that it I don't know, I had to take that with a grain of salt. So this guy right here is the main transformer. And it's kind of funny because everyone calls these welders inverters and not transformers, but the truth is that all welders have transformers in them because they are needed, because your wall outlet power has essentially too high a voltage, like 240 volts if you're plugged in a 240 circuit, and lower amperage. So like a 50 amp circuit, that's not enough to really weld with an 1/8 inch 7018. So the whole purpose of this guy is to step down that voltage from 240 to more like 30, 35 running voltage at a much higher amperage. In the case of this machine, 225 amps. So that's the purpose of this guy. Now this right here, which kind of looks like a transformer, a toroidal transformer, is not. That is a output inductor or a choke. In welders' terms, I believe they call it a reactor. And the only time I've ever heard that phrase used for a choke was basically a welder. Now that is used to clean, typically anyways, again, I'm not an expert in this stuff, is used to clean up the output of the DC rectified output. Because with the setup that's in here, what ends up happening is this transformer just converts the AC to, like I said, lower voltage, higher amperage, but then you need to rectify that into DC. And the rectifier, all that really does is create a signal rather than going positive, negative. It puts a signal only on, say, a positive side. Okay, so you don't have negative voltage in a wave like an AC wave. Well, that output can be like this, where it's not perfectly smooth. Having an inductor or a reactor helps smooth that out to where your DC output in a way isn't pulsating really fast. So it gives you a smoother welding. Now, I've welded a lot with these. The one that I had a long time ago that ended up actually getting stolen from me, that one I welded 2 tow trucks and a ton of stuff with. And I'll tell you, the arc on this is actually pretty smooth. That's something that maybe in part 3, I'll have to put this sucker on an oscilloscope while I'm welding, and we can look at how clean the DC output is. And that's something that, not that it's necessary to do with every machine, but it's pretty interesting because a lot of machines don't really put out that clean a DC output. And they weld okay, it's just something to know. Now, getting in more of what we got else in here, again, I'm not an electronics expert. We have a lot of little transformers and MOSFETs and relays. One of the things I'll admit that I'm a little confused of with this is that when you weld on 240 volts and you go below 70 amps, you can hear like a relay in here toggle, like it's switching to lower voltage. Now, this machine is set up to run on 120 or 240, but even when you're on 240 and you weld at settings that 120 will weld, some mechanical switch in here switches. And I see there are 2 relays in here. That must be what's switching. I just don't know why. Again, I'm not an electronics expert, but I thought that was interesting because I've never had a dual voltage welder that had like a relay that actively switched something internally. As far as how this is able to run dual voltage, well, I would imagine the transformer really doesn't care what voltage that it has as long as it doesn't short out due to high voltage. Okay, so my guess is, and the knob kind of coincides with it, is that it basically does most everything the same on lower voltage. It's just that the output you get is, how do I put it, is just lower. So all the modules, everything in here operates likely assuming the same voltage. And again, I don't know what those relays do, but the output's less. Now, these capacitors here could be used for any number of things. This does not have power factor correction on it, which is part of the reason why its output and its efficiency is far lower. Now, one of the viewers had mentioned something dealing with the power factor and how that can affect the efficiency. And by efficiency, what he was implying was that the accuracy of using a clamp meter to determine what this is actually consuming could be off if the power factor is off. And I'm not going to go in depth too much about that, to be honest, but he isn't wrong. He's absolutely correct. And a device like this, which likely is not the cleanest of operating, if you catch my drift, and it's definitely not efficient, that could play a role. For the sake of my testing, I'm not really going to determine what the power factor of this is. So you're going to find that in my testing of it, like in the previous video with electrical testing, the accuracy of wattage consumed is going to be plus or minus 10-15%. Okay, that's just the nature of it. I am not scientifically testing these, but I will test it in the future and show how much amperage we can get on a 30 amp circuit on a generator. And that will undoubtedly prove that this is nowhere near as efficient as like that little Esab welder over there is. Now, moving on here, the control board for this is pretty much all up in here, which it doesn't really need one because it's just a simple rotary dial and one toggle switch for voltage. The layout of this whole thing, to me, is pretty simple. And I gotta be honest, if something ever failed on this, there's a chance, a hope and a dream that a guy at least somewhat savvy with electronics could repair it. And what I mean by that, you open this thing up and you got one of them brown shit stains on it, you would know, okay, that component's bad. You could pull part numbers and probably solder a new one on. This is not like a fancy, computer chip full welder. So this actually, on the repairability scale on 1 to 10, I'd give it probably a 7 or an 8. You could probably repair this if something happened. And there's so few components on here, the reliability of this would likely be pretty decent. And speaking of that, another person had commented, and I don't disagree with him either, is that he wanted to see like a long-term reliability test. Well, here's the honest truth. I could go and weld with this for 6 months straight and it might be fine, and then you could buy the same one in the last 2 weeks. I mean, the nature of it, that's why you buy a decent brand and you buy one that has a decent warranty if that's what you're afraid about. The warranty on this thing, I think, is 90 days, or you can buy the 2 or 3 year. That's up to you. But I can tell you that these things have proven to be pretty reliable, and they're pretty well known. And that's something like, don't get me wrong, I do reviews on this channel, but I'm not here to try and steer you guys wrong and steal your money and say, buy this and it's junk. I mean, the reality is these things, anyone can get a dud and anyone can get one that could last 10 years. These things are, I don't want to call disposable, but you have to understand that modern welders and 60-year-old transformer machines are two different animals. You can't expect these things to last forever. So anyways, enough ranting. Like I said, the heat sinks seem pretty decent in here. Now let me show you some other things that I find kind of interesting with this. So now that we're on the other side of this, I don't know if you can notice what I'm noticing. I'll give you a minute just to look at that. But the amount of dead space in here is almost unbelievable. Now, no, this isn't a beer, it's ginger beer. So don't rat me out to the boss, but this almost fits inside of the dead space in here, which I kind of really didn't understand why that would be in there like this much. And I got to thinking, and my thought is, and it goes back to what I was saying before, is that Harbor Freight probably has 1 million of these cases, and depending on what factory the welder comes out of determines what board, what transformer, the components. And my guess is this is designed this way to allow for a multitude of different components to be installed in the same case. So no matter what factory it came out of, you could get a functioning welder. But they could easily, I mean, the only thing that's on this side is the power switch, which would easily fit up here, and the input cord. That's it. So they could have made this welder 4 inches, not 4, maybe 3 inches, 2.5 for sure, narrower, and it'd be the same size as the Esab. Why they chose not to, like I said, I think it's just because of revisions. And this thing has been out for quite a long time right now, and this is probably, I didn't see any part numbers that would say like revision 2, revision 3 or whatever, but I'm sure this is not identical to the first generation one. So it's possible that components got downsized over time as they came out with like a more efficient design or as components got cheaper. Now, beyond that, I'm not exactly sure, and if you guys have an opinion on it, please leave it. This stuff is basically like silicone caulk like you would find in your bathroom sink. I'm not exactly sure. I get why they put it over some of these terminals that stick out maybe a little bit further, but then other ones don't have it on it. And why they're on these capacitors or resistors, whatever these are, and not these. I don't know if it's just a hodgepodge that they got going on there, and I just find that weird as to why they would have done that. Now, part of me was like, well, maybe it's just to prevent shorting out on there, but like I said, I mean, the case is 2.5 inches away from that. Like, what on earth would even touch that? So, I don't know, maybe it's to prevent corrosion. I mean, there's intake over here, I don't know. Whatever. Now, here is, and I'll zoom in on this sucker. I'm sure you can't read this, but these switches here, which is a simple toggle switch, I am telling you, whoever Harbor Freight buys these from is terrible. Everything I've ever owned from Harbor Freight, the switch is the first thing to go. I guarantee you this switch in the long run will probably fail. So if you own one of these and you go and turn it on and it doesn't work, I give you a 99.9% chance it's this switch. These things, no matter what tool, they don't last. And I got to reading on this, and it was pretty interesting because it is rated for 250 volts, which is good. They didn't use, something meant for a 12 volt car or something, car system, but it says 30 amp rating. I find 30 amp kind of laughable because this thing pulled 23 amps to output 120 amps on an 1/8 inch rod. So how many amps do you think this is going to pull through a 30 amp switch? 45, 50 maybe to max this out. So this switch in no way, shape, or form, honestly, is rated for that kind of a load. So I find that kind of interesting that they did that they were able to get away with that. And you look at this wire size here, which must be 10 gauge, it has to be. And then it's got this terminal, and then I'm sure it goes to a cheap little, oh, I see it. I'd have to take a little, it's hooked on the little, there's a hole in there and it's got a little tooth. Anyways, on a little cheap chrome spade terminal. So yeah, without a doubt, guys, I'm not joking. This switch will fail you when you need it. So that's something almost, I don't even know if there's a switch like this rated for 50 amps or not. But that's something that, I don't know. You might want to look at upgrading that right away just to avoid problems in the long term. It's a thought. Not necessary, but it's a thought. All right, let's go back to looking at everything else. So it has decently sized brass or copper bus bars that go to the terminals. So that's a good sign. The way that they're staked to the board, they're bolted through and then a little solder connection. When I flip this sucker around, I'll have to take a closer look at that on the other side to see if that's really a decent setup or not. Again, this thing's rated at 225 amps. If I was going to market this, I would have marketed it as probably a 180 amp machine and focused on that more than the 225. I'm sure this will output 225. Unfortunately, on my generator, there's no way that I have enough power. You'd need a 50 amp outlet, and I only have a 30, so that's, unfortunately, I'm limited. But to me, I think they should have downsized the output on this. Now, the reason, again, they can get away with that is that, one, well, there's no duty cycle at that rating, and two, the average homeowner or home gamer is never going to run 225 amps out of this thing. I mean, you'd need a pretty decent sized rod for that, so they get away with that. And I think the reason they marketed it as that is so that people would see this as like a tombstone replacement. Because you guys got to remember, when Harbor Freight first came out with this, they also had that Vulcan brand Commander, I think they called it, that big giant AC/DC transformer stick machine that was like monstrous and cost like $600. This was like the smaller version, the cheaper version of that, but this thing outsold that big unit 10-1, and people love these things, so they discontinued the bigger Commander and then just kept making this. Again, popularity. All right, let's go back and look at the other side real quick. Now that we're back on this side, there's a couple other things I want to mention. I like the fact that on these cables that are run through the hot section of this welder, that they have this silicone stuff that's likely fairly high temperature resistant. That's a good sign. Even on the output to the transformer, they have it, if you can see in here. Same thing on this. It shows that they gave at least enough of a shit to do something to help mitigate heat issues. And what I mean by that is simple. This is pretty thin wire, like the jacket. If that were to, sit here and rest on this, get hot enough and melt that jacket, you could be in a major pickle because that would short these two wires out. Now, these are just for the cooling fans, but if something else, like some of the stuff up here even has it, like that could be far more of a serious issue in shorting out stuff. So that's a good sign. The other thing is that you can see all this white schnot that they put on everything. And this stuff is actually harder than a lot of it, the stuff I've seen inside of welders, but that's to help hold stuff from wiggling. Like you can imagine this capacitor here, which sits out, I don't know, about 3 inches. If you were to set this sucker down hard, that much weight only held on with a couple solder connection through the board could, over a few, not that you're smashing it, could break that off. So the fact they have some reinforcement on key components, again, that's a good sign. And I'll tell you what, I've opened up a lot of cheap welders, like I have Amazon special ones, and they don't care about any of that for the most part. So it's a good sign. Like I wouldn't put this thing anywhere near in the trash category of like an Amazon special welder. They clearly cared about, doing a little bit, just a little bit extra, and attention to details matter. Now there's a couple things too. This is not marketed as a, how do I put it, like a environment resistant welder, and meaning like, oh, you can weld in a light mist or whatever. Like looking at this, there's no indication that thought process was put towards like moisture ingress, water resistance, or any of that. I mean, the way the case comes together. So this is not something that would likely survive that long in an outdoor environment. And when we go into that Esab over there, you'll understand exactly what I mean by that. So this, if it's sitting in your shop or you want to set it on a trailer you're welding outside, more power to you. But the durability in harsh environments is going to be somewhat limited. Now, the good news is the way the fans are kind of set up is that a lot of the dust, I think, will just stay down here in the heat sinks and probably won't get everywhere else. But, it's still, if this is in a really filthy environment, you can expect to get grinder dust on these components, and over time it may short them out. And maybe that's why on the other side of the board, they put all that snot over the connectors. Maybe they had a problem with dust building up in there and it would short it out. So they did that to prevent that from happening. It's a thought, because over here, metallic dust resting on stuff other than this board here, it's not really going to get at the connectors much to short anything out. So that's kind of my thought on it. Other than what I mentioned, and I'll put a close-up couple pictures of this so you can see it as well. I'm kind of surprised at the number of name brand components in here. And what I mean by that is, like, I've heard of like some of these component manufacturers, like for the relays and the MOSFETs in here that I can see, like they're actual, like not like Chinese lettering, no company name components. Is that a good thing? Bad thing? Well, it's nice to see. What does it mean? Well, who knows? So here is your little electrical efficiency tag and information about this, which most welders should have it. You probably should avoid any that don't, because it probably means that they'll burn your house down. But very simple. This, again, it's a stick power source, so they do depict that. And this line depicts that it's DC, rectified DC and not AC current. It lists 2 different outputs, and that's because, well, it has 2 different voltages. It can run on 120 or 240, and it gives duty cycle, all sorts of stuff. Now, one of the interesting things I saw here was it lists the max inrush, or actually just max, at 42 amps. Okay, now they're probably saying 240, that 42 is likely at its rated power, which in the case of this, its rated power is probably like 150 or 60 amps, because I tested it, and at about 125 amps, it was already pulling, I don't know, like over 25 amps. So there's no way at 220 it's only pulling 42. It's probably over, it's closer to 50. but hey, it is what it is on that. Now, this is not UL listed. However, it is CSA listed, which is quite interesting. And it also says conforms to ANSI/International Electrical Code. And that's quite interesting because if you know anything about Harbor Freight or cheap welders, Intertech is often the standard or the certifying agency, whatever it is that they use. And the fact that this is CSA, this has to meet a lot higher, in my opinion anyways, and I think the reality is it's true, standards. And because of this CSA is why this thing is only rated at 70 amps on 120. Don't get me wrong, it's not very efficient, and you would get a lot of nuisance breaker trips if you were trying to, say, run 90 amps, but they were smart and they built this thing relatively compliant. Now, again, I'm no electrical engineer, but the only thing janky about this that I saw is really that switch. They should have never done that, but beyond that, the fact that CSA and not Intertech is a good sign in my opinion. So looking at everything in here, it's surprisingly not as janky as I would have thought it would have been, so that's a plus. And it's definitely safe, I would say, to plug in the wall, which is great. What are my thoughts on the long-term projected reliability with this? Well, I owned the first generation of this, welded it with it a ton, and had no issues. These are fairly well known to last a long time. And so realistically, based on what I see, the reliability other than that switch in the back is going to be really good. So for the minimal investment of sub 300, I'm sure this thing's going to last quite a long time. And if you're handy with electrical stuff, if you do accidentally overheat something or something just fails, it might be fixable on this. So durability should be good, longevity pretty good, and for the money, definitely I think it's a good deal. The last thing I'll mention, and we're going to go over to the Esab, I thought it was cute that they put a little rod chart on this. I never noticed that before, and it's kind of laughable though. They list, hey, 60-10 settings, all right, they got 532 rod, 3/16 rod. It's like, well, yeah, I guess it would run a 3/16, and then 7/32 rod. It's like, wow, okay. And down here they even talk about running 3/16 70/18s on this, which I think that's asking a little bit too much on this, but at least it has a nice chart. That's pretty handy. Oh, and it even has 70/24 settings on it. Awesome. Well, let's go over and look at the Esab. So right off the bat, a completely different layout, a lot of different components that we didn't see in the other welder, and I'll talk about those as we go through it. But the overall design shares no distinguishing characteristics that are similar to the other welder at all. Now, a lot of what you're seeing here is different because this has different capabilities. This unit can do TIG, high frequency start. This whole module right here, I looked over this pretty decent, appears to be for the high frequency start. We'll talk about that. This module down here has to do with the power factor correction that this has. The transformers are different and it has more transformers in here. And up here we have MOSFETs and IGBT modules that are down below. This thing is a hodgepodge of electronics, so quite interesting. And you haven't even seen all of them because there's still more stuff on the front panel, on the side, and we'll get into all of that. So let's start up top. So this whole board is the high frequency starter for TIG arc. Now the other welder did not have that because it does not do TIG welding with high frequency start. The Rogue 180, so the stick-only version of this, and by stick-only I mean it doesn't have high-frequency arc starter, would likely not have this board at all. So that could be a difference. But this appears to be likely a high-voltage coil. So similar to like what you'd find in your ignition system in your car. This right here, which I did not realize it had, is basically a set of points. And let me zoom into that. So it might be a little tough for you to see, but those two little points there have an air gap between them. And the point of those is this coil over here ramps up the voltage really high, sky high, and then as soon as the voltage hits a certain point where an arc can basically jump from one point to the other, it will do that. And the air gap is what controls the voltage that it starts at. So these points are adjustable in the sense that how they're bolted in here, the gap can be changed, but it's kind of factory preset, and this is glued down, this casing, so I don't think you're going to easily be adjusting these. Now, I have adjusted points on older Dynasty and Precision TIG machines, all of those old school, they all had points. More modern machines, not that this isn't a modern machine, but like Miller and Fronius and a couple others, they use what's called a solid state arc starter, and they don't rely on a coil and these points set up to start an arc. So is this a bad system? No, these are pretty reliable. The only thing I would wonder is in the long run, this thing might get some issues with hard starts for arcs, and it's going to be because of these points. You may be able to adjust them, but it's going to be a pain. So like I said, this is a whole arc starter board component. You would not see that in the Rogue 130 or the 180. Over here, this whole back board here, which I'm going to be very careful where I touch in case capacitors are still charged, that is the main controller board where there's capacitors, IGBT modules, all of that is through components through this board back here. This over here has to do with the power input. It might be a relay of some sort. I'll have to take a look, but let's get repositioned and look at the switch back here. So this board right here, I'm not positive. It's probably used for, depending on what voltage it detects, as to where it sends the power. I'm not positive, but that's a possibility. But take a look at this switch here. It's pretty crazy. They wrapped it just like in a, I don't know, in the bag it came with or something. So pretty interesting. Yeah, and it goes all the way, yeah, it's totally wrapped up with that bag. So obviously they must have done this because it's at the back of the welder, and if you had water condensation sit up here and it dripped somehow through the case, and the way this case is constructed, it'd be pretty hard for water to get there. But these terminals are somewhat not open, but long story short, you don't want water dripping on the switch. So that was kind of a good thought on their part, because if water did hit that, it probably wouldn't cause any problems. So that's at least some thinking on that. Still strange. I've never seen that before on any electronic components. The switch itself, I can't really read. It has a part number, but I'm sure it's probably rated at least at 30 amps, and I don't know that this welder would pull 30 amps maxed out anyways, so we'll give it a pass and say that is probably rated at what it should be for this. So this is the power factor correction board. Now there's probably some more capacitors that are part of this that I don't see here, and they're likely inside of this component, this plastic housing. And this is something that the Harbor Freight does not have, and this is part of the reason of why it's so efficient at multiple voltages, and that it'll work arguably better on a generator than a conventional inverter welder. And not that this is really that expensive of a component to add, but cheaper welders typically don't have that therefore their efficiencies aren't going to be as good. Now, the interesting thing is, much like on Harbor Freight, we have like this, some of these are silicone. This is almost like Nomex or something, like fire retardant. So again, all good things to see inside of a welder. We don't see too many bare wires, especially on the side where it could rub up against something. Like you look here, like if this moves around, that little bit of extra jacket will go a long way to help prevent something from shorting out. So one of the unfortunate things is that this is what they call like a wind tunnel design. So you have a single fan, as far as I can tell, back here and in a housing, and then you have like big aluminum heat sinks inside of here that the components are attached to on the other side, and air gets sucked in through here, pulled through and blown out the back, but we can't see the components. Now, is this a good design? Well, absolutely it is, for two reasons. One, as this fan runs, and it's a fan on demand, it doesn't run all the time. If your shop is like mine and full of grinding dust and other crap all over, well, for one, the fan on demand won't pull much material in there because it only runs as needed. And two, all that dust is primarily going to be focused inside this housing and blown out the back. On the other side that we're seeing here on the top and over here, you're simply not going to get the amount of grinder dust that could possibly short something out, into the components. So that's a great design, and that's something that you find on higher end welders. Is it an end-all be-all? Absolutely not. The downside is that, well, you can see to try and take all this apart to get in there to fix something would require complete disassembly of that. So that doesn't make it easier, that's for sure. Let's take a look at the other side. So much like the Harbor Freight, we have a ton of this stuff. Shmoo. Stuff reminds me of some crap I played with as a kid. I think it came in a peanut, like magic putty or something. It's what it looks like and feels like. Weird. I'm really thinking, so this is likely where all the through-hole components are. So like big capacitors are likely hooked up to here, IGBT modules, whatever. And this is likely there for the purpose of grinder dust and other things settling and shorten it out. By covering it all, you can never have that happen. So that's a smart idea there. Now this also has like I can't remember what they're called. It's basically like a coil of wire, and they put them to prevent interference on a lot of wires. Like up here, we got one down here. Oh, if I could remember the name, put it in the comments, but they're to help prevent interference and stuff. So that's interesting. They have a ton of those on stuff. Also, and I'll zoom in down there. So this little blue box is a coil of wire that goes over this output cable, and that's when it displays the amperage you're actually running at while you're welding. It's actually monitoring it with this device. So that's pretty cool. Now the Harbor Freight didn't have one, but it also didn't have a readout, so it didn't really need one. Like I had said, this is a custom fan back here. It does not appear to be a standard PC fan. It's probably like a 90 or 100 millimeter. And that is sitting in this sort of wind tunnel that's set up. You have really big aluminum heat sinks on the other side of this, and they're all in line with the singular fan in the back. So a little bit different design than the Harbor Freight. Now the Harbor Freight, the fans run all the time, and because they're only 80 millimeter PC fans, they're pretty quiet. This is a little bit louder when running, but it doesn't run that often. And when you're done welding for like a minute or two, it shuts off and it's nice and quiet the way I like it. So not really a detriment there. So the power cable comes in back here, and this is about the only janky thing that I've really found on here so far, is that the cable comes through, and look at this. This is just sitting here. Well, granted, this is a ground cable, but, and this, well, the case isn't bolted together, but you can imagine if you're shaking this around quite a bit, over time, that's going to rub. So what I'm going to do before I put this back together is put a simple zip tie loosely on this to kind of hold these together to keep it off of that. So that's kind of a, and this right here goes to the case ground, but, a little bit just to hold it off of there would have went a long way. Not to cover this again, but I don't know if you can see it, but they put like clear silicone over all of the components on here. And this is the front of the machine. I didn't notice that before, but that's a pretty good idea because again, if moisture were to leak through the front of the case down here, this would somewhat help it from immediately shorting out, at least give it a fighting chance of surviving. So much like that plastic bag on the back switch, this will help corrosion problems and any kind of maybe slight moisture that could creep in. All right, so we're looking in through the side of the case. It's hard to shoot a video in here and get everything in focus. But what we got going on here is this guy right here is a output choke. Like I said in the other Harbor Freight welders, just appears to be a little bit bigger. I believe, I'm not positive because I can't really see in here, I believe this is actually using 2 output chokes. I'm not exactly sure why, but that other unit appears without a doubt to be just a coil of copper wire, so an inductor, and it has two of them. So pretty interesting. Now, that big spool of wire back in there appears, there we go, appears to be the primary transformer. Now you're probably asking yourself, well, how is this donut in the front a choke or a reactor, and how is that other donut a transformer? And the reason is that when you look at this, this is simply a bunch of copper wire wound around a core, and we don't have 2 sets of wires on it. This is a transformer. It has essentially 2 windings on it, a input and an output, or realistically a primary and a secondary. And this is what is used to take that high voltage and then reduce it down to lower voltage, higher amperage. And like I said, this and this guy are used to smooth out the output after the AC from the transformer is rectified back into DC. Now, there's also a second transformer, it appears, or it could not, definitely is a transformer. I don't know if you can see that. So there's a second transformer down here. I'm not exactly sure what that is used for. It's possible, and it's my thought, that that switch on the back, or the board on the back top, that I said that when the computer detects what voltage, it switches the transformer. What may be going on here is it's a possibility that this has 2 output transformers and it uses one or the other depending on what voltage you're running on. And that's a possibility to get the best performance. The other possibility is that is used as a step-up voltage transformer to where it feeds the main transformer 240 volts even when you're running on 120. So my guess is it's one of those 2 that's going on in this case. I could be wrong, but that's my thought. Now it does have this little anti-conductive sheet that covers up everything over here, and it also, again, would keep moisture from accumulating. Not that there's vents on the side of this, because the only inlet's here. So the Harbor Freight has vents in the side, so you could get far more stuff in there. This, again, is somewhat redundant, but I guess if the case ever got crushed, it would, not knock the case into here, which this is definitely far more important on this machine because there's no setting a beer in this sucker. I mean, there's like maybe 3/4 of an inch clearance. So it's definitely more important to have more protection on this over the Harbor Freight. Oh, and by the way, I'm an idiot. This I thought was the power cable because of how big it is. This is actually a gas hose for the TIG output. The power cable, I thought this was the negative cable. Well, the actual power cable in here appears to be 4 gauge. and it's probably metric, so I believe it's going to be similar in size to the wires that are on Stinger, so like 5 gauge. So it does have bigger power cable than I thought, so that's good. I know you can't see it, but back here, even they put that like silicone liquid over everything to where if like water were to set on it or magnetic grinder dust, it wouldn't short out. A lot of the components are also held with this same type of schmoo snot that like the Harbor Freight had. Now this does likely have big capacitors as well as big heat sinks. I mean, this is actually an entire heat sink back there. It's not visible in here. And again, you know, I wish I could take this apart more, but I'm a little afraid, especially because I'm not quite right in the head yet from being sick, that I'd ever get it back together. And this is too expensive of a toy to have sit around in pieces. And that's kind of why I wanted to finish this video up, so I can get it back together before I forget what I have to do to put it back together. All right, I'm going to give an overview and then we'll kind of go to the conclusion. So based on what I see in here, I can tell that a lot of care and effort went into the design of this. I mean, the simple fact that they put all this waterproofing stuff, and maybe not waterproofing, but all this silicone on this stuff all over will help prevent corrosion from happening on all these terminals over time. That's a great thought, and I haven't really seen that on a welder, and I've taken apart maybe 10 or 11. And, you know, so I'm not the most experienced guy, but that's pretty uncommon, and I like that. For the most part, I don't really see anything too janky in this thing. I don't like this power cord crap over here. They're one zip tie away from having that fixed, or some kind of built-in cable retention right here. So I'll fix that. Would it have ever failed? Probably not. I mean, this edge isn't really sharp too much. I mean, you know, over time it might, but the design of this, I like it. I don't have too much bad to say. Now, there is something that I will say. The serviceability of this is, for a home person, is going to be very limited. And there's a couple reasons for that. One, let's face it, the components in here, a lot of these, they might be available, but so many of these little capacitors and MOSFETs and all this stuff, like the way this is designed, it's going to be by far harder to service anything in here and troubleshoot it, because it's far more complex versus that Harbor Freight. The reliability of something like this, how is it? Well, this is still fairly new. The jury's out on long-term reliability. Based on what I see in here, I think the long-term reliability is going to be really good, because the common reasons why welders fail, which would be like shorted out components due to grinder dust or corrosion, almost all of that has been mitigated just in the design. So that leaves like individual component failures as being a problem. Well, I have a feeling if this has a component failure, it would probably give you an error code, and you as a home gamer might be able to fix this yourself. Like if the high frequency board goes out, well, how serviceable is this? Not really too serviceable, but you could likely replace this yourself and not be out your welder. So that's good. And the component availability of this, I assume, will be by far better than like the Harbor Freight. I don't think I can call up Harbor Freight and say, hey, give me this board. They'll look at you like you're crazy. Maybe with Esab, you can contact them and they will sell it to you. Hard to say on that. I've never had to do that. I really got to looking, and most of these boards are all revision 1. This one is revision 1.1, so they likely had an issue with the original high-frequency starter system, and they went to a revised setup. So that's good. That shows that they at least care and probably want to fix their mistakes. Or maybe components weren't available during Corona. Who knows? But the design, like I said, everything, I like it. It's just not going to be that serviceable. And I'm going to talk really quick on reliability. let's be honest, guys, this thing is not going to be anywhere near reliable like some old stick welder that's a transformer from the 60s or your Lincoln Tombstones. And I know a lot of you guys get that, and I'm not trying to be a Debbie Downer about it or form an argument. It's just that is the reality. When you get into those old transformer machines, like even a simple Lincoln Tombstone, the reason they're reliable is because literally all they are is a big transformer and a bridge rectifier on the output, or a full bridge rectifier, and that is it. Like, there's nothing to them. So unless a wire on the transformer shorts out or the rectifier blows up, which those are easy to replace, it will work forever. The problem with those Tombstones, especially even the DC one, is one, you can't get more than 120 amps DC output. Two, they're massively power hungry. I mean, you'll never run one of those on a generator and get any kind of output unless you got like a 15K generator, okay? And the adjustability of them, you can't tune arc force, you can't tune hot start. Don't get me wrong, a lot of things have been built with similar equipment, just more industrial to a Tombstone. And even Tombstones, you know, my father had one. He built a ton of crap with it. So you can do a lot with them, but this, no, it will never be a Tombstone. It'll never last 50 years. But at the same point, you know, do you want to lug this around or a Tombstone? You know, which one really will do more for you? And that's, I don't mean to make an issue out of this, but I think, you know, we have to at some point accept shortened longevity of stuff in order to get better performance, you know. And to me, this thing isn't so much about like the better performance like you're probably thinking, but just look at the size of it. I mean, to have 200 amp capability in something this portable, this efficient, is kind of mind-blowing. And I'm okay with the fact that, no, this thing isn't probably going to last as long anywhere near a Tombstone. But they made a really good effort to try and have this be a reliable welder. And also, let's face it, if you want a reliable welder, it's probably best to get a full-size one and not a small one. You see how compact this is, how poor the accessibility is to fix anything. When you compare it to like my full-size Rogue 235 and how open and accessible and easy to access everything is, it's miles better on that. So if you really want better reliability, it pays to get a full-size non-compact unit. The lifespan of these will always be less, I think. With that said, let's look at the sticker on the bottom of this that talks about its certifications, and then we'll go to conclusion. All right, so quite an interesting placard here, and I didn't notice it before on this because, well, it's on the bottom and I didn't think to look there. But this isn't too unlike the Harbor Freight unit. Depicts what process it uses. It depicts open circuit voltage, its duty cycles, and I have a whole video on this that I'll put a link in the description so you can learn a little bit more. Again, it shows DC output. Very interesting. Now, because this has TIG capability, it also lists TIG as its own unique duty cycle and everything. Generator requirement, it lists at 230 volts. You probably can't see, it's not in focus, but 7 kilowatts. And that would, I would assume, would be running watts. Not positive on that, but my generator outputs a little bit more voltage than that, and it is 9500, so that isn't an issue because it does over 7,000 running. Up here, so you guys know, made in China. So this is made in the same place that the Harbor Freight is, but obviously how it's built and the construction and the materials used are completely different. Now this Mark of the Beast Intertech is ETL is on here. However, it says it's also certified to CSA, and it also says conforms to UL standard. So this actually has 2 certifications, CSA and Intertech, and the fact that it says it at least conforms to UL standard is a good thing. I would definitely say on that. Couple other things. Let's see here. Yeah, it lists the revision 01. So this is actually a second revision, and this is likely not the original one, which if you remember on that high frequency arc starter, that was the second version of that. So that's something that they likely changed or upgraded. Interestingly enough, down here it says inrush max on 230 volts is 30 amps. So that is going to be significantly less than the Harbor Freight. However, this is only a 200 amp unit. The Harbor Freight is a 225, but like I said, the Harbor Freight is significantly less efficient. We saw that in the previous video. All right, well, let's kind of go to conclusion. So we really dug in and looked at these in more depth than I planned on doing, but we learned a lot, or at least I did. Hopefully you did as well. And we saw that there are stark differences as expected, and that this is not just a simple game of spending, a couple $100 more and getting minimal gain. The difference, despite both of these being made in China, is staggering, and it's amazing what, $600-700 gives you in a welder. Now, when you get to like this level, spending more money on like the Miller MaxStar 161, you're really not going to be gaining a huge amount more, or like the Fronius that's similar to this. At that point, the difference in another 1,000 isn't as different as these two are. It's minimally better than this, at least in my opinion. But obviously, this Esab is better built. It has way better resistance to moisture and corrosion, and it's a better design. Now, I say that somewhat tongue-in-cheek because does that mean this will last longer? In a harsh environment, yes, but just sitting around in the average person's shop, Murphy's Law can kind of apply, and the amount of things in here, the capacitors and the computer chips and all of that could possibly fail, having 5 times as many of those as the titanium 225, and keep in mind some of those in here because of the TIG function, the 180 has far less components, I believe. But having all those components could mean in the long run that if any one of those fails, this thing could go down, and it's going to be fairly costly to fix, etc. You guys get the picture. So buying more of something doesn't mean better reliability. I think if you worked out of your pickup truck or your trunk of your car and a generator for a couple years, I know this thing is likely going to outlast that in harsh environments. But just in your shop, both of them honestly are probably going to be pretty similar. As far as actual expected lifespan, well, I can tell you that I had this guy for the first generation for a couple years before it got stolen from me, and I didn't have any issues. So I would say for the average person, you're going to get 5, 6, 7 years out of this. If you're using it 40 hours a week, probably 3 years would be my guess, 2 to 3 years. But you only paid less than $300 for it. How much money do you want for return on your investment? I mean, this thing, for the average person, you do a couple side jobs, and this will pay for itself. This is going to take you maybe 10, 11 side jobs to pay for it. But, which one would you rather have? Well, honestly, I'm not going to sugarcoat it. I like this guy, okay? But I understand budgets are a real thing, and there's nothing wrong with starting out with this or using this as your only stick machine, especially if you don't do a whole lot of stick welding. Nothing wrong. There is something wrong, and I'm not trying to make fun of anyone, if you go cheaper than this with like your Amazon specials, okay? And I don't want to make this, this is better than everything else out there, but I'm just being honest. When you get into like them Yes Welders and a lot of the cheaper ones on Amazon, they can't run 6010. They barely run 6011. The durability and long-term reliability is, I guarantee you, is going to be worse than this machine or this one. And if you really, you got to look at it as a little bit of an investment. you know, $100 Amazon special versus this, save your pennies and buy this. If you're down to like, I only got $350 and I want to learn to stick weld, buy this. And then if you like it and you make money, buy this. There's an acceptable minimum level to start. It's kind of like a guitar. Think of it like guitars, okay? $100 guitar is not a good place to start. A $300 to $400 guitar is a very appropriate place to start, generally speaking. And a $5,000 guitar isn't going to make you a better musician than a $300 to $500 one. Start with something that checks all the boxes, that isn't a complete turd, and you'll be just fine. So that's kind of, I guess, my opinion on it. And if you guys have a differing opinion or saw anything that I didn't cover that you'd like to add, whatever, feel free to share it. And I appreciate that anyways, because I read the comments and stuff. So with that said, thanks for sticking around for the whole video. Hopefully you enjoyed it. And I will have a part 3 of this where we're going to max out my generator and see exactly how much amperage I can get out of both of these on the generator to conclusively prove the numbers behind that. And once I'm done with that, I will also do a whole video on how to run a welder on a generator and sizing generators for welders. So, because I know I'm only about 6 months late on that. So anyways, thanks for sticking around. Till next time.